So now we're going to do absolute value inequalities. Friday when we did this and we solved absolute values, how many answers did we need to come up with? Two. That part stays the same. We're still going to need 2 answers. Okay, so if this was Friday, my absolute value is by itself. I would write it just how it looks without the inequality bars. Okay? Well, that part stays the same. And then I change the sign on the other one. That hasn't changed. What's going to be different now is I got to flip that inequality. So, exactly like it was, flip the inequality, change the sign of that one. Now, the absolute value is by itself, right? Yes or no? Yeah, okay. I don't have to do any math on this. Why not?
Oh, because it's going to equal 0? No?
When is an absolute value bigger than a negative number? An absolute value is never bigger than a negative number. You want to bet? What are absolute values? Is that a bigger than a negative? So absolute values are always bigger, not never bigger?
Always bigger?
Absolute values are always bigger than a negative number.
Yeah.
Yeah.
Okay. You said the opposite of that previously.
Did I?
Yeah.
I knew what I meant. Absolute values are always bigger than a negative. Okay, so graphically, this is what you would be looking at. There's my grid. Okay. There's your absolute value. That would be that part, kind of. Here's your negative 20. So, one way you can look at this, is I want to know when is the absolute value up above negative 20. Like when we were doing inequalities with linear inequalities, we had the y on the left. We turned this into a p or a d. You remember doing that? Okay. So my inequality is on the left. That's what I want to happen. Would this turn into a p or to a d? A p. So when is the absolute value up above negative 20? Always. Another way. When is the blue up above the red? Always. So your answer you end up with is all real numbers. Does that make sense if I say it right? Okay. So number 8 here. Absolute value is by itself. Okay. So we're going to write it just how it looks but without the bars. So 5 plus 2v is less than 7. Then we're going to flip the inequality and make the other thing negative. So 5 plus 2v greater than negative 7. Okay, solve for v. 2v less than 2. V less than 1. 2v greater than negative 12. V greater than negative 6. What kind of points do I have? Open. Okay, so I have an open point at 1 and an open point at negative 6. And they're going, well, if you go to the left, negative 1, and to the right, negative 6, they're going at one another. So from 1, we're going to the left. From 6, or negative 6, we're going to the right. So these two things end up being connected. So graphically, there's my absolute value. We'll say that's 7. So what is this asking? We're what? Where's the absolute value below 7? it's below 7 in here. So your intersections would be -6 and 1, and it's in between those two intersections. Where's blue below red? Where's the absolute value below the 7, or below the line? Does that make sense?
Yes.
Yeah? Okay. Turn it over. Alright, let's go ahead. I can't remember what I did. Okay, so we'll do 9 and 10, and then I'm going to talk about something when we do 10. So 9, again, the absolute value is by itself. It's on the left. So if you were going to picture this in your brain, okay? Picture this in your brain. When I do this, and I find the answer, should the arrows be going at one another, or should they be going away from one another? At one another? Away from one another? We have at, and we got two options. Let's agree on one and then see who's right. Alright, let's see what happens. Let's see what happens. Okay, so 7n plus 2 greater than or equal to 19. 7n plus 2 less than or equal to -19. So I got 7n greater than or equal to 17. Greater than or equal to 17/7. -21. So I have a closed point at -3 and an open point at 17/7, which is like a little more than 2. Okay, so I'm going to the right of 17/7 and to the left of -3. So all of you at people. Alright, where's the absolute value up above the line? Where is the absolute value up above the line? So what does this one say? With using like normal people words, what does this one say? Where's the absolute value above 13? So are they going at one another or away from one another? They're going away. What about this one?
Toward one another.
Towards one another? What about that one? No.
No.
Okay, so, because you divide by negative, so it flips. Okay, so here's what we're going to do. We're going to look at some stuff in the calculator real quick. Alright, so I'm going to do 9 and 10. I'm not going to use the whole equation. We're just going to use part of it. So, if you look on here, I have the part on the left for number 9 and y1. I got the part for number 10 and y2. Don't do y2 yet. Okay, just do y1. So, the absolute value of 7x plus 2. If you don't remember how to get the absolute value, push math, arrow over to number, and then push enter. It'll bring your little lines up on there. Then we'll graph it. Okay, there is my absolute value for number 9. And next week you'll learn how to manipulate these. Okay, there's my absolute value for number 9. So now put number 10 in there. Put number 10 in there and then graph it. Keep number 9 in there. Keep 7x plus 2 in there. But put the absolute value of 5 plus x plus 3 into y2 and then graph it. What happened to it as far as up and down? What did it do? It slid up. What made it move up, you think? The plus 3. Yeah, our plus 3 moved it up. Okay? But even though it moved up, is 13 still higher than 3? So we can still keep that same kind of visual in our head as far as where do I think the arrows are going to go. Okay? So, like on number 10 here, if I just picture it, I'm going to know it's going to go up 3. So it's going to look something like that. It went up 3. That was a horrible V. But then I know we still have 13. I still know that. Even though it went up, the basic idea of what you should see in your brain looks like that. Okay? Absolute value is not by itself yet. So we'll go ahead and get it by itself. So I have the absolute value of 5 plus n is greater than 10. Okay? Now it's by itself. So we can drop the absolute value bars. 5 plus n greater than 10. 5 plus n less than negative 10. Oh. We end up with 2 n's there. Okay, so from our picture, we should have figured that, okay, my answers, when I get them, they should be going away from one another. When you end up with your answer, I have greater than 5. That's going away. And then less than negative 15. That's going away. So we're good. Does that make sense? Sort of, kind of, not at all? Okay. So 12. We have a negative in front of our absolute value. It would be flipped. So it's going to be flipped, like he said. Is there anything that's moved it up or down? Huh? No. So I just end up with an absolute value that's opened upside down. And a line somewhere up here at 85. So what does this want to know then? Where what?
When the absolute value is greater than 9.
Mumble again. When the absolute value is what? Below 85. When is the absolute value below 85?
Always.
All the time. All the time. Here's another way you can look at it. If I isolate the absolute value, 2a plus 1, it's got to flip because we're going to divide by negative 5. Greater than or equal to negative 17. When is an absolute value greater than a negative? Always. So you end up with all real numbers. If you had, this is just because I don't have one of these on here. If we had the absolute value of 2a plus 1 is less than or equal to negative 17, what would you say then? Well, we've come up with solutions. We've come up with all real numbers. What's our other one? No solution. So if it's always, it's all real numbers. If it's never, then it's no solution. What? Okay. 14, and then we'll call it a day unless you want me to do some more. Fine, I won't do any more. Okay, so absolute value is not by itself. Go ahead and get it by itself. 1 minus 5x less than 12. Okay, so in your brain, at one another, away from one another. I did say, meaning visualize it in your head. Sorry. Visualize it in your brain. Give me the answer out loud. At one another or away?
At one another.
We think it's at. Okay, so if I go ahead and draw a picture. What? How what? There's your absolute value. So there's that part. There's 12. So there's your other part. Where's the absolute value? Down below 12. Down below 12, it's at one another. because it's touching. They're going at one another. They got to touch. So then all we got to do is find our intersections. 5 minus 5x less than 12. 1 minus 5x greater than or equal. Where did that come from? Greater than negative 12. Making stuff up. Negative 5x less than 11. So x is less than negative 11 fifths. Negative 5x.
Yeah,
Switch it. Dang it. Oh, at least the whiteout worked today. Divide by negative. Good to see if y'all were paying attention. I got negative 13. So x is less than negative positive 13 fifths. So going in towards one another. So negative 11 fifths, about how much? A little bit over 2. So is it going to be to the left of negative 2 or to the right of negative 2? To the left, a little bit to the left. Okay. What? Okay, 13 fifths. A little bit more than 2. And they're going at one another. Alright, what do you think? Good to go?